Okay, in this problem here we have a population of meerkats, and meerkats are in units of 10, so if n is 1, it's really 10. And t is the years. The rate of change of the population is modeled by this differential equation. We're given that n equals a plus bt. We want to find a and b. Is a solution to this particular differential equation. Find the values of a and b. Well, if it is a solution to that differential equation, one of the things I know then, if I take this equation, if I find the derivative with respect to t, I end up with b. So therefore b must be the same as this scenario because they're both the derivative. So it is equal to 1/2 n minus t. And so 2b is equal to n minus 2t. And so I know that n is equal to minus 2b minus 2t. Now, if we recall, if we look down here, here's the equation. And so if I take that and compare it, I have n is equal to a plus bt. That means that b equals, hold on, I fixed my math here. This is going to be a positive and a positive. Is b is equal to 2, and a is equal to 2b, which means a is 4. And so the equation is n is equal to 4 plus 2t. And that's going to come handy later on. Okay, so now when we go to b part, we have our slope field. It says on the slope field, put this equation. So I'm going to go to this scenario here, and I'm going to put the equation on. Let me make it a bit bigger so I can see it better. And so I'm going to put the equation on here as 4, and I know it goes, slope is 2 up 2 over 1, up 2 over 1, and it is doing that particular graph there. It then wants me to find the trajectory if t is 0 and n is 2. So my trajectory then, I am here. That means I'm going to follow the path. It has to be a 0 here somewhere. And then it's going to probably go down something like this. And so these meerkats on the green curve are going to be extinct at this point here. So then it says, find the least number of meerkats in the colony at t equals 0, so that will ensure the population does not become extinct. Well, if I look at this slope field here, if anywhere down here, the slope curves downwards. And so what I know, anything when this starting value is 4, less than 4, it's always going to become extinct. But on the top side of 4, it will always grow larger. And so I know then if n is bigger than 4, then it will not be extinct. So if I look at this line here, it is a constant growth rate. It's always going to keep growing on a linear rate. Below here is going to be extinct. Then above here, it will start to grow more so. Now, going to D part, environmentalist measures the population calculates. It will reach a maximum after 3 years and then will decline. Well, if I consider that, there's a couple ways I'm going to do this. I'm going to look here at 3. If I go up here at 3, I can see from my slope field that it looks like approximately here is the maximum. And then it's going to start to go down again. So now that's approximate. So I don't know if that's 100% true. But what I can do, that if I look at my differential equation, dn dt is equal to half n. If I substitute in my 3 here, if it's a maximum, it means the derivative is 0. And so then I can find the value of n is going to be 6. And so this means 60 meerkats. is what is happening at that point. That's the population at that time. Moving on to E part, it says, at t equal 3, they decide to introduce more meerkats from another colony. If the remaining model remains valid, find the least number of meerkats we would need to introduce for the colony to increase continually. Well, if I think about that, what's happening there is at this moment in time, if I switch to blue, at this moment in time, there are 60 meerkats. In order for for the meerkat population not decline, it's got to be above this line here. And so if I use my line, n equals to, what was it again? 4 plus 2t, 4 plus 2t. When t equals 3, I get 4 plus 6 is 10. So I need in total n to be 10, which is actually 100 meerkats. 6 is 60 meerkats, so here's 6, here's 100. I need to add 40 meerkats in order to the population not to go extinct. And then finally, the last one for Euler's method, you're going to use the equations. If I do t n minus 1 is equal to t, sorry, let me try that again. I'm going to do t n is equal to t n minus 1 plus my step is 0.1. My n is going to be n minus 1 plus 0.1, and then I go to my derivative, which is up here, 0.5 nt. So 0.5 n minus 1 minus t n minus 1. And I'm going to do it upon the introduction where I know that my starting value that I'm going to do at t equal 3, n is equal, after the introduction of extra meerkats, the size part is this. Use right, I have 100. I have 100 meerkats, means n is 12. And then I'm going to go for little n equal to 10, and I should get 153 at the end.